In this video, we are going to talk about resolution of vectors. Before we talk about resolution of vectors, it's very important for us to understand what do I mean by projection of vector, or you can say the shadow of the vector. Let's look at that. Suppose I have a vector like this. Let's say this is a vector a bar, right? And this is the ground, suppose. Now, suppose there is a source of light which is directly on this ground, right, above this ground, like this, and the light rays are coming vertically downwards. Then I will see the shadow of this vector like this, only this much, right? Only this much shadow I will see. For example, if I keep the marker pen, so there is a light coming from here. I keep it like this. The length of the shadow is nearly equal to the length of the marker. But if I keep it tilted, the shadow length is decreasing, right? The shadow length will decrease, and at this point it will become a zero, right? Similar way I can see here. So now the shadow of this vector along this ground, and let's say if this angle is theta, is how much? How will you calculate that? So you know this is a magnitude A. What will be this? Of course, you know cos theta. Cos theta is adjacent side. Let me call this shadow as AX, as it is along the x direction. So cos theta is AX upon A. So AX is going to be A cos theta. AX is going to be A cos theta. Now this is the shadow of this vector along x axis, right? Now this is nothing but a projection of this vector along x axis. This is called a projection of this vector along x axis. If the light source is like this, then suppose there is a wall over here and the projection light is along this direction, then what your shadow you will see is this length, right? Will it be A cos theta? I don't know. Let's check out. This length is going to be equal to this length, right? Let me call this length as AY. So this is going to be AY. Now, if I use sine theta over here, sine theta is equal to opposite side AY upon A. That will give you AY to be A sine theta. So now you can see the length of the vertical shadow is A sine theta. This is the projection of this vector along this direction. AX is the projection of this vector along this direction. So now you can see this is what we call projection, right? Okay, this is a shadow, right? Now if theta becomes 0, AX is going to be A. That is obvious because this angle, if it is decreasing and it becomes horizontal, then of course the length of the shadow has to be equal to the length of the vector, right? As you see from this marker, length of the shadow is same as the length of the marker. If theta is 90 degree, then it is totally vertical and this shadow will become 0. The length of this shadow will become 0. Cos 90 is 0. Okay, so this is the thing I wanted to tell you. Now we will proceed with the resolution of vectors, right? Okay. Suppose we have a coordinate system, x-axis and y-axis. For this case, I am going to talk about two-dimensional resolution. Suppose I have two directions, x direction and y direction. There is a vector like this. Let me call this a vector a bar, and let's say this is angle theta. What do I mean by resolution of vector? The resolution of vector says that this vector can be broken into two vectors, one along the x-axis, another along the y-axis. Let's see how we can do that. What I will do in this case, I will draw a perpendicular like this. Now according to Pythagoras theorem, now as I said earlier, this is going to be a cos theta, this is going to be a sin theta, right? Okay, no Pythagoras theorem is needed. A cos theta, a sin theta. Can I say this is equal to ax? This is a component along x, this is a component along y, right? Okay. Now a bar can be written as some vector according to triangle law of vector addition. A bar can be written as the addition of this vector and the addition of this vector. So a bar can be written as ax bar plus ay bar. Now these two vectors ax bar and ay bar are the vectors which are solely in the direction of x and the direction of y respectively, right? So I have resolved this vector in two vectors which are in certain other directions. This is itself called resolution of vectors. Okay, now ax is a cos theta, ay is a sin theta, right? Now the magnitude of this vector, as you know, will be given as a square is equal to, or you can write a is equal to square root of ax square plus ay square, right? So that is correct, right? This is a Pythagoras theorem. You can say a square is equal to ax square plus ay square, where ax is a cos theta, ay is a sin theta. If you do it, you will get a square cos square theta plus a square sin square theta, which is equal to a, right? So you can write the magnitude of the vector like this: addition of the squares of the components, and then you take square root. Okay, all right. Now I will be little bit off topic. I will go little off topic and tell you something about unit vectors, right? Unit vectors. So unit vectors are the special vectors which have one magnitude and a given direction. For example, suppose there is a vector a bar like this. Okay, the unit vector, this is not a unit vector. Suppose this is having a magnitude a. The unit vector will be the same direction but having a one magnitude. It will have the same direction but it will have magnitude equal to 1. That is what we call unit vector. So unit vector along the direction of a bar will be written as a cap. Here the cap indicates that its magnitude is 1 and it is a vector. It's still vector but magnitude is 1. Okay. So how will I find the unit vector? The definition of unit vector along any vector a bar is defined as a cap is equal to a bar, okay, and divide this by the magnitude of that vector itself. So this is the definition of unit vector. If you see, the magnitude of this will become 1 and it will have the same direction as the original vector. Now from here you can see a bar can be written as a bar mod times a cap. Okay, or if you want to write a bar mod as a, then you can write it as a bar is equal to a into a cap. Okay, this is how you write this. Now the unit vectors along x direction and y direction are written as, along x direction we write unit vectors as I cap. Along y direction there is a unit vector which is denoted by j cap. Along z it is k cap. Some textbook use x cap also, y cap, z cap. Depends, right? Depends upon your textbook what is it following. We will use mostly I cap, j cap and k cap. So I cap is along x direction, j cap is along y direction, k cap is along z direction. So these are the unit vectors with the direction along x, y and z. Okay. Now again we will come back to this one and see. Okay. Now this vector ax bar can be written as, see, this is a ax magnitude I have written. So ax bar can be written as the magnitude of ax. See, any vector can be written as, a bar can be written as magnitude of that vector multiplied by the unit vector in the same direction. So ax bar can be written as ax, the magnitude of this vector ax bar is ax times the unit vector along ax. But the unit vector along ax is nothing but a unit vector along x direction, which is nothing but the I cap vector. So I can as well write this as ax I cap. Similar logic I can use for this one, ay bar. So if I have a vector ay bar, I can write the magnitude of that vector ay multiplied by the unit vector in the same direction. But the unit vector in the same direction is nothing but the j cap vector. So I can write it as j cap, ay j cap. So here you can see a bar is ax I cap plus ay bar, sorry, ax bar plus ay bar. So I can replace this statement by this one. A bar is equal to ax I cap plus ay j cap, right? So this is how you write the new vector in terms of I cap, j cap and k cap. So this is the resolution of vector, writing the any vector in terms of I cap and j cap which is perpendicular to each other. So I cap is like this, j cap is like this, both of them are perpendicular to each other. So now any vector which is in two dimensions can be written in terms of I cap and j cap. Any vector, okay? So this is the thing, right? Now this does not end here. Another thing, suppose if I give you a vector like this, 2i cap plus 3j cap, 4i cap minus 2j cap and so on and so forth, then you should be able to find out the magnitude from that, which is this one. These are called rectangular components. Why they are called rectangular components? Because they are making a 90-degree angle with each other, that's why. Okay, now I want to know the direction of this vector given the components. This is the x component, this is called as y component. That's why it is written ax and ay. Now what if I want to find out this angle theta? Then what you do? You take tan theta is equal to, opposite side is ay and divided by ax. That is simply tan theta, right? So this will give you the direction. So somebody asks you, suppose somebody asks you this question. There is a vector p bar which is equal to 5i cap plus 3j cap, right? And that person asks you what is not 5, I will take 4, okay? 4i cap plus 3j cap. And if this person asks you, tell me this is a vector, what is the magnitude of this vector, then simply you can do this. Here px is 4, py is 3, so the magnitude of this square root of px square plus py square, which is nothing but square root of 4 square is 16 plus 3 square is 9, which gives you square root of 25, which is nothing but 5. So this is what you get. P bar magnitude is 5. Okay. Now what is the angle theta? So angle theta you can write tan theta is equal to y component upon x component. See, y component upon x component, which is 3 by 4. Now what is theta? For 3 by 4, this opposite side upon adjacent side, this angle is going to be 37 degree. You know this 3, 4, 5 triangle, right? So 37 degree is going to be tan 37 degrees 3 by 4. So theta is going to be 37 degree. So this is what you get as an angle. If somebody asks you what is the x component of p bar, then this is the x component. One which is the coefficient of I cap is the x component, one which is the coefficient of j cap is the y component, right? You can find out the angle, you can find out the magnitude as well. Okay, so that's all for the resolution of vector.